Hi, it's Elliot Peterson here to talk about Newton's laws of motion. There are three of them. The first of these laws is the law of inertia. It states that an object at rest stays at rest, and an object in motion stays in motion with the same direction and speed unless acted upon by an unbalanced force. We see this with this motionless car here, with no unbalanced forces acting against it, and same with this car moving at a constant velocity, or actually speed, which also has no unbalanced force acting against it. We can also see this with a spinning top. If I spun it here, and if there were no unbalanced forces at all, here we have friction. See that? Friction at the bottom, slowing it down. It would continue to spin forever. And if it were here, and there were no unbalanced force acting against it, and it would stay that way forever. It really demonstrates it, I think, with the spinning top. And Newton's second law states that the acceleration of an object as produced by a net force is directly proportional to the magnitude of that net force in the same direction as the net force and is inversely proportional to the mass of an object. We see this with this cart here. It has a small amount of mass on it. This force is the same in both of them, but the acceleration is different because the acceleration is inversely proportional to mass. That means the smaller the mass with the same amount of force, the larger the acceleration. Or the larger the force with the same mass, the greater the acceleration. We see that with the smaller acceleration here with the greater mass. We can also see that with a shoebox and shoes. We close this empty box, give it a shove, we see that it moves at, let's say, 3 feet per second with nothing inside it, 0 grams. Let's say that these shoes are 1,000 grams. I tried to give it the same push, and we see that an empty box traveled further because the acceleration is inversely proportional to the mass. The shoes, representing the mass, slowed down the acceleration of this object. Newton's third law is that for every action there's an equal and opposite reaction. The size of the forces in the first object equals the size of force in the second object. Something that really demonstrates this well is a balloon. The action is the air rushing down. And the equal and opposite reaction is the balloon going up. We see this when you let go of a balloon and it shoots up. And the reaction is proportional. You see this with these equality marks. It is proportional. You can also see that with a bouncing ball. The action is the ball is dropped, and the reaction is it bounces up. And though it might not look equal, it is equal. Those are Newton's 3 laws, and we see them all around us. I showed multiple examples for each one. If you have any questions, ask me.